Because a suitable input shaft couldn't be found in Pakistan, they went to a junkyard to search for parts. Unexpectedly, the car owner spotted a scrap input shaft right away. After inspection at the repair shop by Uncle Glasses, it was determined that the cracked shaft could be repaired to like new condition for just 3,000 rupees. The master technician used a hydraulic press to separate the bearing, preparing for the shaft's broken section to be rejoined. But because of an angled crack, direct welding wasn't possible. The master first had to use a lathe claw plate for stable reduction, ensuring the cut line matched precisely. Given that cutting shortens the length, they used copper steel alloy to bridge the gap. After deciding on the splicing approach, they applied high heat to soften the shaft, reducing its hardness to allow smooth cutting. For this three-stage splicing, they removed all areas outside the marked lines until the ends were smooth and flat. To achieve concentric and coaxial alignment, they drilled the gear end center. This not only increased the splicing strength but also maintained the alignment of the entire input shaft. Without cutting fluid, they proceeded cautiously, keeping the lathe speed moderate to avoid affecting the final hole alignment. To ensure a firm bond, a larger groove was cut at the hole's edge. The aperture of the gear end was carefully checked, and the fracture surface was refined to fit the compensation cylinder with a tight, precise seam. After heating to a specific temperature, the turning tool cut the shaft. The master then marked both ends with copper. Now, both ends of the shaft achieved the same splicing standard. The compensating cylinder was embedded into the hole after confirming its depth to prevent any shortness in the reserved length. Since threads weren't used in this docking, the master ensured that the stud's outer diameter was perfectly aligned, using precise measurements. To avoid gaps in the docking, the circular cylinder stud was continuously cut down to fit. The input shaft grooves were also remade to ensure ample welding area. Any minor misalignment in the hole's connection was corrected to maintain concentricity. With both ends of the round steel now protruding, the repaired input shaft met all three-stage docking requirements. After lubricating with oil, the valve head tool was tapped to secure the assembly, followed by careful hammering by the master to maintain precision and prevent any axis deviation. Finally, the entire assembly was rotated on the lathe to confirm concentricity, and after a final check, the groove was fully welded. Since the weld naturally sits higher than the shaft's diameter, the master used a lathe tool to finish the surface, covering all traces of the splicing. An angle grinder was used to polish the surface, removing rust and restoring the shaft's original shine. This scrap input shaft from the junkyard was skillfully repaired by the master using raw steel, achieving a three-stage docking that restored its original length. What do you think of this kind of repair work?
Thank you so much! Subscribe to my channel.